because the decimal is our reference mark that always goes between the ones place and the tenths place. So lining up the decimal points is the same thing as lining up the ones places. It makes sure all the number places line up in columns. Now, you've probably noticed that decimal numbers can have different numbers of decimal digits. For example, 10.8 has only one decimal digit, but 5.34 has two decimal digits. And what that means is that when you line up the decimal points of the two decimal numbers, they might not form a nice column on the right edge. Some of the digits might be missing. But that's no problem. Remember, if there's not a digit in a particular number place, you can just put a 0 there to help you keep track of things. Now that these numbers are lined up by their decimal points, we can add them column by column. But instead of starting with the ones place, like we always did with whole numbers, we start with whatever number place column is the furthest to the right. In this case, that's the hundredths place, so we'll start there. So we add the digits in each column, carrying or regrouping as needed, and we get 1614. So we're done, right? Wrong. There's one last really important step. Remember, we're doing decimal addition, so we can't just forget about that decimal point. We need to bring a copy of it straight down into our answer line, so we keep the same reference point for our number places. Now we can see that the answer is really 16.14. Decimal subtraction works the same way. You start by lining up the decimal points of the two numbers. Remember that the order of the numbers matters in subtraction, so be sure that the number you're taking away is on the bottom. Then, starting with whatever column is furthest to the right, you subtract the digits column by column, borrowing if you need to. After that, you just bring down a copy of the decimal point and you have your answer. There's a clever way that we can make decimal multiplication look exactly like the multi-digit multiplication with whole numbers that you already know how to do. The key is to pretend that the decimal points are not really there. Let's say that you need to multiply 3.65 by 2.4. Now that seems a little tricky, but what if we just pretend that the decimal points are not there for now? In other words, what if we pretended that the numbers were 365 and 24? You already know how to do that problem. You would just follow the procedure that we learned in multi-digit multiplication, part 2, and you'd get the answer 8,760. But that's the answer to 365 times 24, not 3.65 times 2.4. So it's time to stop pretending. To get the correct answer for the decimal problem, we've got to understand what's going on with those decimal points and why we just pretended they weren't there. The truth is, when we pretended that the decimal points weren't there, what we were really doing is pretending that they had been shifted until both of our numbers became whole numbers. Remember, the numbers 365 and 24 technically do have decimal points. They're right there next to the ones place. We just don't need to show them since there aren't any decimal digits. So, by ignoring the decimal points, what we were really doing is mentally shifting the decimal points to the right. We shifted the top decimal point 2 places to the right, and we shifted the bottom decimal point 1 place to the right. The answer we got is way too big. It's too big by 3 factors of 10, because the decimal points in our problem got shifted a total of 3 places to the right, 2 on the top and 1 on the bottom. So to fix that, we're going to have to shift the decimal point in our answer the same amount in the opposite direction. In other words, we need to move the decimal point in our answer 3 places to the left, which will make it smaller by 3 factors of 10. So, starting right here, where the decimal point would be if our answer was 8,760, we shift it 3 places to the left, and we end up with 8.760.